Okay, our first example is going to be here, where um, we have f is 9x squared plus 36xy minus 4y squared minus 18x minus 8y. And g of x is a very simple 3x plus 4y equals 32. So the first thing we do is we find the gradient of f. That's equal to 18x plus 36y minus 18i plus 36x minus 8y minus 8j. The gradient of g equals 3i plus 4j. Taking the derivative of like that with regard to x, that with regard to y. And so um, then we have a typo here. This is supposed to be a plus. Okay. So then we get three equations. So we get, because the gradients are vector equations, so we get an equation with regard to x components of f and g, the y components of f and g, and that the regular g equals 0. So our equations are 18x plus 36y minus 18 equals lambda times the g x part, which is 3. And then so we just did those guys. And then we're going to do these guys. And so that gives us 36x minus 8y minus 8 equals lambda times 4. And then I'm going to do this guy equal to 0. And so then I've got 3x plus 4y plus 32 equals 0. Okay, so here I have a system of three equations, and I have three unknowns. So my unknowns are, let me use a different color to color my unknowns. My unknowns are, I've got x is an unknown, y is an unknown, and lambda is an unknown. And so I have three equations, three unknowns. No variables are multiplied together that or any weird functions, so that makes it linear. So this is the perfect thing to solve with a matrix calculator. So first, let's get them all in the right spots. So I want to have, I'm going to put them into new equations where something x, something x, something x, wait, a little smaller, something x, something x, something x, plus something y, something y, something y, plus something lambda, plus something lambda, plus something lambda equals something, equals something, equals something. That's what I'm going to try to do. So if I put them all in, like each variable gets a column, then I can put the data of those system equations into a matrix. So let's see. So a lot of this is already set up nicely. So I'm just going to change it to be 18x plus 36y minus 3 lambda equals 18, and 36x minus 8y minus 8 minus plus minus 4 lambda equals 8, and 3x plus 4y plus 0 lambda, because there's no lambdas in that equation, equals negative 32. So I'm going to pull up the Desmos matrix calculator here and make a new matrix. I'm going to need another row and 2 more columns. And so the data numbers from that system equation is 18, positive 36, negative 3, positive 18, positive 36, negative 8, negative 4, 8, 3, 4, 0, and negative 32. And so reduced row echelon form of A is that. And so that means that over here, I have that x equals negative 8.59. Let's say 5926. And y equals negative 1.5 repeating. And we really don't care what lambda is. So that's all we really need is the x and y's. So that creates our extrema. And then from there, that tells us then, like subject to that constraint, we can then look at f of that point. And so f is this 9x squared plus 36xy minus 4y squared. So then I can maybe go to my graphing calculator perhaps, or just a regular calculator even. And so I'm saying x equals negative 8.5926, y equals negative 1.5. And so then f of xy equals 9x squared plus 36xy minus 4y squared minus 18y, 18x minus 8y. So f of xy, let's call these constants a and b. That's better. And so then f of ab is that, and f of a plus 0.1, b plus 0.1 is smaller. Therefore, I'm at a maximum. So I can say here that this is a maximum. Just by using calculator. Could have also tried using second derivative test. But I know that this is extrema. I know everything's differentiable. So I just really have to check another point near it and see. All right, so that completes that first example.